So this example is x squared over 4 plus y squared over 9 minus z equals 0. And the graph of this will be an elliptic paraboloid. But before I do that, I want you to ask yourself, how is this equation different from the elliptic cone? How was it different from the elliptic cone? And the thing to remember was the elliptic cone, all of them were squared. So the elliptic cone was x squared over 4 plus y squared over 9 minus z squared equals 0. So notice the difference between the elliptic paraboloid and the elliptic cone. The z here is to the first power versus the z is to the second power. Still 2 positive and 1 negative, but that's our fundamental difference here. So what is this elliptic paraboloid going to look like? Let's first take a look at what's happening in the xy plane. So if z equals 0, we're looking at the intersection in the xy plane. In that case, what do we get? You get x squared over 4 plus y squared over 9 minus 0 equals 0. X squared over 4 plus y squared over 9 equals 0. And all we have is a single point. We just have the single point, 0, 0. So the only place it's going to intersect is going to be at that point 0, 0 in the xy plane. Now let's take a look at the other two planes. Again, we have our usual orientation. X, Y, Z is what we prefer. So if I'm looking at it on the left, we're going to let y equal 0, which is the xz plane. And that's the left portion here, or looking at it from the left or from the right. So if y equals 0, what is that going to give me? X squared over 4 plus 0 squared over 9 minus z equals 0. So x squared over 4 equals z, or z equals x squared over 4. We recognize this as a parabola. Notice it's called a paraboloid, so that shouldn't surprise us too much. So it's a parabola. Looking at it from the left or right, we should see the picture of a parabola. Now, how about if x equals 0? This is our YZ plane. This is viewing it from the front. So if x equals 0, we have 0 squared over 4 plus y squared over 9 minus z is 0. Y squared over 9 minus z is 0. Y squared over 9 equals z. Again, it is another opening upwards parabola. Looking at it from the front view, we see a parabola. Looking at it from the left view, we see a parabola. We see a point, though, intersecting the xy plane. Now, I just want to add one more thing. For example, what if z equals 1? What is that going to give us? That would give us x squared over 4 plus y squared over 9 minus 1 is 0. So we get x squared over 4 plus y squared over 9 equals 1. That is an ellipse. But if z equals -1, if z equals -1, what's going to happen? Let's steal some room down here. If z equals -1, what do we get? We get x squared over 9 plus y squared, excuse me, x squared over 4 plus y squared over 9 minus -1 equals 0, which gives me x squared over 4 plus y squared over 9 equals -1. And that is nothing, right? That has no solution. So there is no value where z is -1. There's an ellipse where z is 1. And then again, we can see we have a point 0, 0 here in the xy plane, a parabola here, a parabola here. Does that give you enough to visualize it? Let's take a look at an image. So the way this is working. We see the x-axis coming out in red, the y-axis in green, and the z going up. The way this is defined, 2 is the denominator of x, so x squared over 4 or a quarter x squared, you could see here, plus y squared over 9 or 1/9.11 y squared minus z equals 0 using this widget. And we can see what that elliptic paraboloid looks like. You see the single point hitting in the xy plane. Do you see the two parabolas? In this direction, we see a parabola, yes? The green direction, that is the y, and then in the x direction with the x and the z, we also see a parabola. So that will give us what? That will give us an elliptic paraboloid. And what did we notice about this? The axis of rotation here, or the axis of symmetry, was the z-axis. So let's go ahead and write that down. So we have x squared over 4 plus y squared over 9 minus z equals 0. And the axis of rotation was the z-axis, axis of symmetry, axis of rotation. Axis of symmetry, axis of rotation is the z-axis. So I hope it's obvious how we would go ahead and change this. If we want to have the axis of symmetry to be the y-axis, what would that be? If our goal is to have the axis of symmetry be the y-axis, well, then the y has to be negative. X and z both have to be squared. So I need x squared over something plus z squared over something minus y equals 0. This should give me an axis of symmetry of the y-axis for my elliptic paraboloid. So let's take a look and see if we get this diagram. So I have x squared plus z squared minus y is 0. Notice the y-axis is the axis of rotation. I certainly could make these things ellipses rather than circles just by dividing somehow, but then notice it doesn't quite look as nice as the other version, but there it is spinning. But indeed, that is an elliptic paraboloid. And if we want to go ahead and have an x-axis of symmetry, what would have to happen? If we want the axis of symmetry to be the x-axis, we'd have to go minus x equals 0, and then I would need y and z to be squared. Y squared plus z squared minus x equals 0. So let's check that. Let's go back to that app, see what we get. So make it y squared plus z squared minus x is 0. And now notice that the x-axis, again, I prefer this orientation. I guess I do prefer the x coming out, y to the right, z up. So indeed, you can see that the x-axis is the axis of rotation or the axis of symmetry. And again, certainly you could divide by things if you want. Divided by 4, divided by 9, divided by 2. Doesn't quite look as nice as an elliptic paraboloid. But that's what it is.